Welcome to CFO 4.0, the future of finance. The CFO role is changing rapidly, moving from cost controller to strategic visionary. And with every change comes opportunity. We are here to help you take advantage of this transition, to win at work, drive your career forwards, and lead with confidence. Join Hannah Monroe, Managing Director of ITAS, a financial transformation consultancy, as she interviews key experts to give you real-world advice and guidance on how to transform your processes, people, and data. Welcome to CFO 4.0, the future of finance.
So hello everybody and welcome to this episode of the CFO 4.0 podcast. My name is Hannah Monroe and with me today is Peter Morgan. Now Peter is the CEO of the Deep Learning Partnership, but he is also the head tutor at the Said Business School at Oxford University, and he looks after the AI program that they have there. So welcome Peter, brilliant to have you on the show.
Yeah, really nice to be here and I'm really looking forward to it.
So this actual episode kicks off our deep dive into the world of AI and particularly around finance. But before we kind of get into the finance application, what'd be great, Peter, is almost to talk about the why now. Why have we seen such an acceleration in AI technology over the past couple of years?
Yeah, that's a good question. So it's kind of been a slow ramp, and I think everyone sort of feels that. But the thing is, it's on an exponential curve. So the last couple of doublings have really brought it into the public attention. So when ChatGPT was released November 2022, just over 2 years ago, the model was a lot bigger than the one before it, GPT-3, and it basically gave it all that extra capability. And so that's really the main reason is the hardware, the data sets and the models themselves, the model size, they've all been on this exponential curve. And so that's kind of brought them to the point where, you know, they can do really useful things. Yeah.
And we hear the term AI models quite a bit. Talk us through what is a model and why is it important?
So basically AI systems are made up of algorithms, and then a collection of these algorithms put together to make it work, we just call a model. So a model is a complicated beast. So under the hood, if you're technical, you can kind of deep dive down into the math and everything, the algebra and the calculus of how these things work. But, you know, instead of going there, we just call them models. It's much easier.
And what sort of things does a model contain?
Yeah, it contains, so these are bio-inspired systems. In other words, they're inspired by the mammalian brain. So nature's done a pretty good job over 4 billion years of evolution of coming up with these natural information processing systems, which we call brains. And so it's like, we want to build AI. Let's look to see how nature did it, right? And so basically under the hood, there are these layers of artificial neurons, which are basically mathematical equations, and they transform data as it comes in, moves through the different layers and comes out the other side. And that is basically, in a nutshell, how these artificial neural networks do work. And they're very similar to how the brain processes information, but not quite. And the details can get quite technical, but basically we're cheating. We're using nature for inspiration, and lo and behold, it kind of works.
And so we use the term, and certainly I've heard it talked about a lot recently, is the term generative AI. What does that mean, and why is that different, I guess, to other types of AI?
Yeah, so there's two types of AI, generative and predictive. And so it used to be all about predictive AI, which is classification, regression, and clustering. And now it's become about generating new content. So, it's always been, we've always had generative AI, but we haven't really had the hardware or the algorithms to really do anything useful, like creating sentences or new images or sound or video. So it's been all about the predictive AI up until a few years ago. Probably 2014, actually, when Ian Goodfellow at Montreal, a student of Yoshua Bengio there. Now, there's three guys, right? Yoshua Bengio, Jan LeCun, and Jeff Hinton, and they're kind of known as the godfathers of AI. So one of his students came up with these things called GAN, Generative Adversarial Network, in 2014. That kind of kicked the generative field off within the research community, but again, it didn't hit the general public until OpenAI released ChatGPT in November 2022. So really, there's only two types of AI, and generative has captured the limelight and will continue to do so for a good few years, I imagine.
So tell us a little bit about, I guess, how generative AI is different from predictive.
Yeah, so it's in the name, really. Okay. Generative AI generates new information. Predictive AI looks for patterns, like draws lines and graphs, and it looks for to extrapolate and make predictions. I mean, it's in the name, right? Predictive AI. Generative AI gets data input. It could be text. It could be images, for example. Could be sounds. Could be even scientific data, and actually looks to generate new data given the input data. Yeah, I mean, it's super interesting. It is the brain, if you think about it, the human brain, we do those two things. We predict things and then we generate things. There's no different. But yeah, we do tend to classify them into those two categories.
And we I also hear the term LLMs. Tell us what an LLM is and why we need to know about it.
Yeah, well, LLMs are generative AI, an example, and they basically, again, it's in the name, large language models. So they're used to generate language, and they do a pretty good job, right? If you've ever used ChatGPT or Gemini or Claude, type prompts in, you get pretty good output these days. Whether it's asking it to solve a math problem or do some coding for us or create an essay. It's pretty good now. So that is kind of, well, that's basically what LLMs do. Now, large language models, they don't only generate language. So really, we should be starting to be calling them large multimodal models. So multimodal data in, multimodal data out. But the name LLMs is stuck. So we may be stuck with that, even though it's a little bit of a misnomer. Yeah, it does more than just language, is what I'm trying to say. It does more than just generate language.
So let's talk about that then. What, like, because again, I think when you're immersed in the technology world, this kind of stuff, talking about the acronyms and the words that people use, it seems obvious. But tell us what a multimodal means and how that, I guess, how that applies. Can you give us some use
Yeah.
cases?
Yeah, sure. So the world is multimodal, and the data, it's actually referring to the data. And so data can come in text, it can come in symbols like code or math, it can come in images and pictures and sounds. Okay. So we have five senses: sight, sound, touch, taste, and vision. So those are the five types of data that we would input, and we can output those five types of data too through creative generation of new data. So the world is multimodal in terms of data, right? Or information. So we can use those two terms interchangeably. So multimodal, we don't want to try to get too hung up. It just means the different types of data. That's all it means.
So we've talked about a lot of acronyms, and what else do we need to know about, I guess, what's changed in the world of AI in the last few years?
Yeah. Okay. So that's a good question too. So basically, these models have got bigger and more performant, and a lot more performant. So if we look back in GPT-3 days, we're talking about 2020. The period between 2010 and 2020. There's a lot of progress being made, but really, 2020 they started generating text in sentences, not just gobbledygook. And so really you can almost, cut AI development into two phases, kind of pre-2020 and post-2020. And then the big bang moment came in the end of 2022 with the release of ChatGPT, but then Google also released Gemini. I think they called it Bard back then. They did a little bit of rebranding, but it all kind of happened around the same time, around the end of 2022, beginning of 2023. The actual output became almost human-like. And that kind of knocked a lot of people back a little, took us by surprise, took the community by surprise, because we didn't actually expect these models to get so good so quickly. And it turned out scale was all we needed. We just scale them up, put more parameters, more hardware, and more data, and the output just became exponentially better as well. And so then people like Jeff Hinton, Jan LeCun, Yosha Bengio, and the community started coming up with these letters for the community to sign to say stop, because we don't really know what we're doing anymore. We didn't expect this to happen. Now, all of those letters have gone by the side because people just want to make money. So we're in this very interesting time in human history where we're building these machines that are as smart as us and as capable as us. We don't really know how they work. And so, yeah, the fear has used to be huge, but now that's kind of died away and excitement's taken over, and people are just build, build, build. So yeah, we're in interesting times.
And I guess going back to some of those thoughts on, if it sounds like there's a slight loss of control in terms of what's happening with AI. So, and you
Yeah,
mentioned that ChatGPT in particular took the AI community by surprise.
yeah,
How did that happen? As in, how was it a surprise?
yeah.
What's changed?
That's a great question, because internally, when OpenAI released the model, ChatGPT, I think it was GPT 3.5, so it was in between 3 and 4. They said, we're just going to do a limited release. We're going to throw this over the fence and see how what the adoption is like. They expected 1 million or so users. Within 2 months, they had 100 million. It was the fastest downloaded app in the history of the world, right? So people caught on really quick, and it's like, wow. Intelligence is cool and sexy, right? People love intelligence. So it just took off, and we just have not looked back since then. So even internally at OpenAI, they just thought, this is a little research project. We'll throw it over the fence and see how people like it, expecting a few people in the community, to sort of pick it up and play with it. Before you know it, remember, it was just coming up to Christmas. It was the end of November, coming at December. Everyone's sort of thinking about Christmas. Come back in January, and it just like took off 100 million downloads in the world. I mean, we just haven't looked back, right? No one hasn't heard of ChatGPT. Yeah, it was a phenomenon. It was crazy. I mean, we've never been here before. The internet was pretty amazing. That took off really quick, but it took a few years, right? Maybe 10 or 20. This is taken 2. So yeah, we're in new territory. Makes it exciting, makes it scary. Yeah.
And I guess the feeling, certainly the more I get involved in AI, the more conversations I have around AI, is that it's not just that we're moving fast. It feels like the pace is accelerating, and it's, getting exponentially faster. So what is driving that change? Why is it accelerating?
Yeah, again, it's Moore's law. We've had Moore's law since the 1970s, when Gordon Moore wrote it down. The number of transistors on a chip will double every 2 years, and we've faithfully kept to that for like 50 years, or a little less, maybe 40. Then it kind of started flattening off, but then the NVIDIA GPUs came along, a different architecture, and that's kept Moore's law going. So it really is a lot to do with the hardware. Yeah, it's definitely Moore's law. Now, that's not a fundamental law of nature. There's nothing in the universe that says physics that says that had to happen, but it has happened, and it continues to happen. And as long as we continue doubling the number of transistors every year or so, these models will keep getting more and more powerful. Yeah. So
And,
we can blame
and we
Moore's law.
And we talk about, I hear the word sort of AI and quantum computing and quantum technology
Yeah.
seems to be also kind of, the two terms seem to be more and more intertwined. What's the connection? What is quantum technology, and how is it impacting the development of AI?
Okay, well, I have a quantum physics background. I did my PhD in physics. I love physics. I'm a particle physicist, so by training, and I, went into IT and then AI and machine learning in the last 10 years. So I know a lot about physics, and I know a lot about quantum physics, and I know how hard. Therefore, I know how hard it is to build quantum computers. So my level of excitement isn't quite as high is some people's who haven't, done a PhD in physics. So we have to be a little bit wary of hype here. And I try not to kind of overhype quantum computing in any way. I think we're still at least a decade away. So I think really that's more of a news story than anything real.
Yeah, so it's not going to impact the world of AI in the near future, as in within the next couple of years. It's a decade plus away.
Yes, exactly. Maybe it will in a decade, but not for that long. So right now we have enough action going on with classical computing, and it's a beautiful thing. Yeah.
So I guess with the pace of change, what are some of the things that, as business owners that we need to consider when it comes to AI? What are some of the things that we need to think about?
Yeah, well, okay. First thing is safety, right? Because these things are so powerful, we don't want to just throw them into production and hope for the best, right? So safety is first. Always has been. Any new technology, we got to make sure it's safe before we deploy it. AI is no different. It's just different in that it's a little bit more powerful and it can be agentic. In other words, it has agency, as opposed to the rules-based computing, which we're used to, which is, you can have bugs, you can have bad actors, you can have hackers, but they're not, the programs themselves are not autonomous, whereas these AI agents are actually getting to the point where they're kind of semi-autonomous, and we're starting to chain these large language models together and having systems of agents that we can give an instructions for a prompt. They will go away and do our project and come back, write some code, do some research, whatever it is we give them. And, we need to know what they're doing, right? When it's doing its research, it's not learning how to build a bioweapon and coming back. When it's writing code, it's not writing code that can be maliciously used by itself, right? So safety is going to be, is first. And so that means regulation, and it means compliance. It means, a lot of oversight. So that really is, the technology is wonderful and great, and these research labs chock full of PhDs in machine learning and computer science and math and physics are doing wonderful, wonderful things. But businesses don't really care what's under the hood, right? They just care that it's safe before they deploy it. So I think that's what businesses care about, and rightly so.
And as a business leader, how do you know that the AI tool that you're choosing to use is safe? What's some of the things you should think about?
Yeah, well, actually, at the moment, it's sort of down to the vendors like OpenAI, Anthropic, Google DeepMind, Microsoft, to guarantee that safety. So before myself or my clients put it into production, they read the documentation and the small print that comes from the vendor. Again, whether it's ServiceNow, Microsoft, Oracle, Anthropic, right? And so if something goes wrong, it better be them that's liable, not the client, not the business, because they didn't make these things. They expect a level of responsibility when a vendor, goes to market with a product or a service. And so really the testing, the onus is on the model providers. Now, given that, no matter what the technology, it's like, okay, great. If liability, it's theirs if something goes wrong, but we're still going to test it before we put it into production. And that's where you do need the capability in your own IT team to actually do the rigorous testing, compliance, make sure it does what it says it does. Put it in a sandbox environment first before you put it into production. Those are the safety steps that businesses will be taking.
And are there any questions? You mentioned obviously reading the fine print, and let's be honest,
Yeah,
a lot of people don't read the fine print. I don't know, how many times do we download an app and not read the terms and conditions that sit on it? So,
of
what are
course.
some things that we should be looking out in those terms and conditions, specifically when it comes to AI?
Yeah, I would say privacy first, right? Is your data being used? How is your data being used? When we type into a prompt, or a business types into a prompt, it's probably putting some proprietary information in there. The last thing we want is for OpenAI or Anthropic or anybody, Microsoft, Google, to be using that data to train their next generation of models, right? That cannot happen because then everybody in the world has access to your proprietary information, which will come out in the next generation of model. So that's got to be the first thing. In all of the enterprise editions of OpenAI and Anthropic, etc., Gemini, they in writing state that we will not use your data for training, and the free versions they might. So be very careful which version you're using. Yeah, because they will use data for training, because that's how the models get better, with not only the hardware but the training data. So the onus is on us to understand where the data is going and really take time to check. So you're 100% sure, because we've already had mishaps where people type in prompts and it's gone out, and people say, "Oh, look, I think Samsung is a pretty high-profile case when they accidentally put a lot of their proprietary information into a ChatGPT prompt a couple of years ago. That was not a good look for Samsung. So yeah, reputational damage. You got to be very careful.
Hey Google, what's the best accounting software for my business? Give it a couple of years, and I bet you she'll be able to answer you pretty accurately. But for now, it's still one of the few questions Google can't give you an answer for. But we can. Take our free quiz and find out which Sage product is the right fit for your business. Just head to itassolutions.co.uk.
And what are the other risks that we need to consider when evaluating whether AI is the right tool to deploy, or thinking about our AI strategy as business leaders?
Yeah, there's a ton of risks, really. We've talked about, you mentioned data privacy and reputational risk. There's as many risks as we can, possibly think of, really. So, leaking data, but also these models not doing, or doing something unexpected would be another risk. So they hallucinate, right? And because they're statistical in nature, not deterministic, it's just by nature, these neural networks, they will give a different answer. You give them one input, they'll give a different answer each time you put that input. So we have to be careful that we check the output. So that's one thing. The accuracy of the output needs to be checked, and that's still an issue. Maybe in a couple of years that won't be such an issue, but today it is. There's been a lot of progress in that, using various techniques. To make it so it's more accurate more of the time, but we're still not there. So banks, healthcare, they require, and telecom require 5 nines, 99.999% accuracy. Their SLAs, service level agreements, demand that, or else they get fined, right? The customer can turn around and say, well, you went down, or you gave me the wrong answer, 1% of the time. And in your SLA, it says, 99.001%. And so we're not there yet. So a lot of super regulated industries like finance and healthcare can't use them in a lot of areas. So there's that risk of, inaccurate output, basically. Data privacy is another one. People hacking, but that's no different, really. There's called prompt injection, where bad actors can put malicious prompts if they get through your company firewall. But that's sort of, with normal IT as well. So, I guess specifically for these large language models, it would be data privacy and inaccurate output. Those would be the top priority.
And we've talked a lot about large language models. Are there other types of models that we need to consider or think about? Is LLMs the key type of AI that we're seeing in today's world?
Yeah, that's a great question. So there's a lot of progress, right? There's probably 100,000 PhDs inside of Google, Microsoft, and these Chinese companies like DeepSeek and Alibaba and Baidu, working every single day, round the clock, to come up with better architectures, more accurate models, more performant, And so we can expect to see maybe new architectures, new hardware, different, more high quality data sets. So, it's really the most impactful technology humankind has ever invented. So everybody is accelerating, like you said earlier. So this stuff is accelerating the whole time. We don't know when these sort of breakthroughs in quotation marks will happen, but they happen. We've already seen a few. DeepSeek was the classic example 2 months ago, and they were China company, their hedge fund, were using, kind of underneath the radar. They were using reinforcement learning as part of their information processing. And the big labs like Google, Microsoft have been doing that, but only experimenting with it. China beat them to the post there. And so that was a breakthrough. 2025, we'll probably see 3 or 4 major breakthroughs like that. In 2026, it'll just keep going. Super exciting field. Again, exciting, but we have to keep on top of it, because these models, when you get a breakthrough, they become more powerful, so they can do more good, but bad actors can use them to do more harm. So it's a double-edged sword, right? This whole process.
So tell us a little bit about, what was it about the DeepSeek piece that I guess was considered a breakthrough? What did they achieve that was over and above what ChatGPT, for instance, developed?
Yeah, well, they use the transformer architecture. So all of these models, Google wrote a paper, Attention is All You Need, in 2017. And that became what I like to call the $10 trillion paper, right? So it's actually spawned, all the architectures are based on transformers. So DeepSeek, you can kind of tweak that architecture and add stuff, take stuff out, add new stuff in, be as funky as you like, right? Be as creative and imaginative, because science at the end of the day is a creative pursuit. And so they added reinforcement learning to certain parts of that large language model, all the different layers. And yeah, they did a few tricks. I think they published a 40-page white paper, which is, open source that as well. So they didn't try to keep any of it secret. When OpenAI, DeepMind, release a new model, Anthropic, there's no like, here's how we did it. It's more of a black box. But the DeepSeek guys did. So you can actually read the paper and see exactly, you can look at the math, right? Because at the end of the day, this is math, literally math and statistics. Yeah.
Yeah, well, I must admit that's going back to my heydays. I was a maths grad, so you're a physics grad, I'm a maths grad. So
yeah,
this is where I get super excited. So talk to us about the reinforcement learning. What did that drive? How did that impact those language models? How did it help them learn faster?
Yeah. So let's. There's 3 types of learning. There's supervised learning, where you sort of give the model labeled data, and it just it compares the output to the labeled data that it's already been trained on. There's unsupervised learning, where there's no labels on any data. You just kind of throw all this stuff, unlabeled stuff. Could be text, could be images. Just here it is. You don't know what it is, and then it has to use clustering algorithms to kind of put it into buckets. That's another type of machine learning. This is all machine learning, by the way. We call it AI, but it's, 10 years ago, everyone was calling it machine learning. Now it's AI because it's more trendy. But this is all machine learning. And it's just giving machines data, digital computers data, and letting it learn from the data. So you have labeled data, unlabeled data. Now, reinforcement is when you kind of put it in a virtual environment and give it rewards, positive rewards, if it's getting closer to the objective function. Say it's playing chess or Go, whatever. That's the famous DeepMind, winning at Go, and giving it a negative reward where it moves further away from its objective function, which to win the game or come up with a new scientific theory or create a new video, for example. And so that's reinforcement learning. Now, these big models are a combination of all 3. And it's where and how you use supervised, unsupervised reinforcement learning. The architecture will be quite similar. It's layers and layers of artificial neural network, artificial layers. Each layer can be different. It can be, so the depth and the width will vary. The big models have over 1 trillion parameters. And the human brain has 100 billion neurons, as an example. So they're kind of more complex almost than getting up to the complexity of the human brain. Right. So this is why the output is equivalent to the human brain, or sometimes better, because they're have the complexity of the human brain. And so, it's basically how you combine supervised, unsupervised reinforcement learning more than anything else, really. Reinforcement learning is reinforcement learning, supervised is supervised, unsupervised. It's how you put it all together, what architecture you use based on the transformer. You might take out this layer, put in a new layer. It's a very empirical science. So you do raise a great point. There's no mathematical theory about how these things work. Too complex, the complexity too great. So, it's empirical. You throw in an extra layer, see what happens. You take a layer out, see what happens, that kind of thing. Yeah.
So really experimental, sort of like learn by doing. The more you change, the more you figure, the closer you get. Fail fast, basically.
Yeah. Well, this is why we had some surprises along the way, right? We don't really know until we build them and try them out. And it's like, wow, that worked much better than we thought. That's cool. We don't really know how it did it, but it works. All good.
And I guess I'm going to ask the weird and wonderful questions in terms of what does the future hold? Because, if we look back in sort of 20 years ago, a lot of this would have seemed literally science fiction. We would have said, oh, that's not possible, or it's going to be 2050 before we get there. Having seen, I guess, what we've achieved and what's happened in the last few years, how, what are your concerns, I guess, as we move forwards? What's the worry that you hear in the community around what AI can do for us?
Right. I'm super excited about what it can do in scientific research. I want to cure cancer and I want to live longer, healthier, and we all do, right? So it's fantastic. The upsides are amazing. Let's keep building them better and better, bigger and more performant. But then it's like, okay, let's stop bad actors from using these super powerful to create bioweapons, because people will do, the people will always do bad things, right? And some people, and for whatever reason, whether they're state actors or individuals or whoever, right? And so we really have to try to keep these things safe, these super powerful tools, which is what they are really, digital tools. We have to try to keep them safe. Members of the public I can't just walk into a nuclear power station, even though I have a PhD in physics, and say, hey guys, show me the reactor. It's like, no, you have to, be vetted and come through the fence, and where's your paper. We'll have to do that with these models. They'll be too powerful just to let the general public, you and I, use some of them for sure. Yeah, which is a little unfortunate, but that we can't go into nuclear power stations either, or army bases. So the military will definitely have tools that we don't have access to. Put it that way. Yeah.
And we've talked very generally about AI, and I think that's the really great position. I guess, when we think about the world of finance, particularly the world of business finance, what are some of the use cases that we might want to get excited about in terms of how it can help us?
Sure. Well, there's portfolio optimization, there's algorithmic trading. So anything that financial services companies do today, hedge funds, enterprise banking, investment banking, retail banking, the boring stuff, the exciting stuff, the high frequency trading stuff, portfolio management, insurance, risk management. These tools, once you train them on that data, right, and every data, whether it's Bloomberg, JP Morgan, HSBC, have their own, special proprietary data sets. So they will have advantages in those areas. So what they'll be doing, probably already have done, is training these models on their data and getting a competitive advantage by doing so. So not just relying on humans and classical computing, but actually starting to use machine learning and large language models now to get an edge in portfolio management, risk management, trading, everything. They're pretty good already. Honestly, they're very, very good at most things. So they're only going to get better. So unless you use them, you'll fall behind, right?
And somebody once said to me, it's not that AI is going to take the jobs, it's just that somebody that knows how to use AI is going to take your job. And I thought that was a really great quote to consider, particularly in this day and age. So how do you prepare your business and the business that you work in and your team to embrace AI? What are some of the things that you need to think about?
Yeah, well, actually, the more the person knows about the technical ins and outs, the better off we find. And so I mean, we're kind of a boutique consulting company, so we have kind of PhDs in machine learning to hold the customer's hand. But then there's all the other layers underneath that, just the pure business layer as well, risk management and all of the other stuff that goes along with running businesses. And specific domains. It could be HR, it could be finance within a business itself. So all of those application cases. So that's where you need domain experts, not so much the technical deep depth, but the domain depth. It depends. I mean, there's Accentures, there's the McKinseys. They have 1,000, PhDs basically with machine learning degrees, and they also have all the business guys as well. And so quite often, a deeply technical person won't have the business skills and vice versa, so that you can go in as a team. And that's what we're finding, because you need both, right? You need the technology awareness and expertise. And if something goes wrong, you have to know how to fix it. And you have to be able to tune and optimize and maybe fine tune these models on your data. That takes a level of technical sophistication. But then you need the business guys to actually, know how to use these tools in their business domain. Yeah, that's pretty
I
much
think
it.
it's like any data analytics tool. It's not necessarily the ability to pull the data. It's what you do with it and how you interpret it that actually drives the value within that tool. And I think that's one thing that we can be really conscious of as we go into this new world, is that the finance skills and that business acumen that
You're
we've gained. That's the bit that we need to apply, those technical skills to make sure we're
right.
making the most of it.
Absolutely, yeah, because the technical guys know nothing about, what any other industry does, except, they just know how to build these tools. So yeah, it's going to come down. But there is that overlap, right? You can't just kind of throw these things over a fence and say, yeah, go and use it to do X, Y, Z. It's like the more the domain people know about how they work, the better off they'll be as well, the more competitive advantage. So there's going to be the next few years, and maybe even a decade, it's going to be a lot of training people up on these new tools, I think. Yeah, that's a business opportunity there we're seeing. Just training people. Education is a big thing.
And it's an exciting, I must admit, it's an exciting new world. So just to finish this off then, Peter, for any business leader listening to this, what are your top tips for starting your AI journey?
Yeah, okay. So experiment with the tools. Start off the shelf. Use ChatGPT, use Gemini, use Claude. Maybe even use Microsoft Copilot, because that's really set up for enterprises. Depending on your budget, but just get a feel for what they do, right? Impress yourself and have a few wow moments. It's like, oh my God, it can do that. Wow, that's going to save hours, every single day of what that guy over there used to do. So we'll give it to him so he can do 10 times as much for her that they used to do in a day. And it's like, oh my God. Like you said, if we don't use it, somebody who is using it, we'll go out of business if we just let other people use it. So definitely get comfortable with it. Get a feel for what it can do. I'm sure most people have by now. 2 years ago, it wasn't the case. No one knew. I could talk to people, have you tried GPT? And it's like, no, another newfangled, just hype, it will go away. It's like, no, you don't get it. You have to use it. You would never be saying that if you just use the tool. It's like, wow. Okay. And they've only got better. And they're getting better. Especially technical people, software engineers in particular. It's such a great use case, and scientists. They're just using it, right? Because it's a software tool at the end of the day. It's a type of program that's built with software, and so they're quite comfortable with trying new things. But the guy in a retail environment or just they're not that used to they're used to say, okay, this is Microsoft has given us Microsoft Office, we'll use that because it's safe and reliable, and everyone else is using it. They're not at the point where I don't think they're ready. They see it as a risk, right? And there's a lot of people, I'm not going to put numbers, but I'd say only 10% have fully embraced this technology. And the next decade, by 2030, I think it will just flood through organizations and automate so many parts of workflows. and be super disruptive. It doesn't mean everyone's going to get out of work. It just means we'll be so much more productive if we learn to use these tools. The other thing is the other side, slightly worried that something really bad will happen and they'll kind of put the brakes on. And that normally happens, right? We've had the nuclear reactor meltdowns, 3 Mile Island, Fukushima, Chernobyl, and suddenly, no one wanted to build nuclear power stations anymore. It might happen. So that's the other thing that I'm sort of bracing for that when that happens. I'm sure it's going to happen before 2030, right? Yeah, you can't just build these powerful tools and nothing go wrong. So that's the other thing. Yes, double-edged sword.
Prepare, hope for the best, but prepare for the worst, I think is the catchphrase there. Well, thank you so much, Peter, for sharing your insight and your information. If people want to learn more about yourself and what you do, where's the best place to find you?
Yeah, just deeplp.com. Deep Learning Partnership. We have a website. I've written a ton of blogs about the new developments. And do find me on LinkedIn as well. So thanks.
Thanks so much, Peter. And for all of our listeners, this is the start of our AI journey. So my piece to you is to say, well, what are the questions that you have? What parts of this topic would you like us to explore as we go forwards? Because, we've only just touched the surface in this first session. So I'd love it, if you've enjoyed the session, reach out, tell me, give me your questions. What are some of the use cases you're coming across, the questions you're thinking about, and what's in your brain as you go about your day job about how you can use AI in finance. So thanks so much to Peter for joining me today, and we'll see you next time on the CFO 4.0 podcast.
Thanks a lot. Bye now.
So for those of you that don't know what we do here at ITAS, so we are a financial transformation consultancy that specialises in Sage technologies, whether that is looking at a new solution, evaluating your current solution, or just helping you to get the most out of your current setup, we can help. But rather than me tell you all the reasons that you should consider working with us as a Sage partner or a transformation consultancy partner, I'm going to let our customers do the talking for us.
ITAS were there from the sort of get-go, helping us, talking through what the process was going to involve, setting expectations, making it clear that how much work we were going to have to put in to make sure that the project was a success at the end. And then talking us through all our different options, looking through our current processes, making us reevaluate what was important, which elements we wanted to move across to the new system, how we wanted to configure our new system, and also kind of making us sit back and really think about what is the success of this project when we get to the other end, when we finish the implementation and we're in the system, what's success going to look like, and actually putting that question back to us and really making us sit down and think about what is it that we are looking to gain from this whole process was really useful internally, making us really think about the key objectives and which areas to maybe prioritize over others. It was also really helpful sitting down and thinking about it rather than one big huge project, actually splitting it down into different phases, sort of smaller bite-sized chunks, which made it seem a little bit more achievable within the time. And then thankfully ITAS have been super flexible with us during this process, because it happened to coincide our implementation with our first ever financial audit, which just took up huge amounts of our time that we didn't expect. So we did have to slightly push back some of our go live dates, and thankfully ITAS were accommodating and actually helped us navigate through that process. And like to say that thankfully we're out the other side of our first phase of go live, and loving the move to Intact.